This is a video on how to write basic Lewis structures. If you have your rules for writing Lewis structures handout, I'm going to show you how to do the basic ones, steps 1, 2, and 3. I'm going to do the one on your example. I'm going to do water. Okay? So to draw a Lewis structure, this is basically just an arrangement of where all the valence electrons are. These are for covalent structures. It shows us how they are shared. So the hydrogens are going to share with the oxygen. But we first have to count, in step 1, how many valence electrons there are. So I have 2 hydrogens, so that's 1 plus 1, plus 6 for oxygen. Okay, so I have 8 valence electrons. Step 2, you want the most symmetrical arrangement of atoms as you can. Hint, hydrogen's never in the middle. Second hint, the least electronegative element's going to be in the middle. So for water, oxygen's going to be in the middle and hydrogen's on either side. Step 3, this is a really important one. Some videos that you see don't mention this, but I want you to listen to this. Always give the central atom 8 electrons first. Give 8 electrons to the central atom first. In pairs, not ones, in pairs. 2, 4, 6, 8. Well, I only had 8 electrons to work with, so I'm done distributing electrons. Let's see what I have. If you look right here, that's called a lone pair.
Code blue, room 203. Code blue, room 203.
That means that oxygen is hogging those electrons. It's hogging those electrons for oxygen itself. Now, these guys in the middle, those are called a shared pair. That means that hydrogen and oxygen both can claim these. It's like going to a potluck dinner, somebody brings potato salad, they both get to eat the potato salad. Same goes for these 2 electrons. Hydrogen only needs 2 electrons, oxygen needs 8. So as you can see, everybody's happy with this structure. One last thing. The shared pairs, if you want, you can substitute with one line. That's totally up to you. That's what you want to do. So an alternative Lewis structure would look like this. Okay, I'm going to do a bigger example. I'm going to do SO4 minus 2 charge. Now it's got a charge on it, so watch what I do with this. I'm going to count up all my valence electrons again. Sulfur has 6. 4 oxygens, each one has 6, so that's 24. Minus 2, guess what? We're anti-math here, so minus 2 means to add 2 electrons. That's where that comes from. Minus 2, add 2 more. This adds up to 32. You're going to like it when you get 32. It's a nice, easy structure to draw. Okay, we look at this. What's the most symmetrical arrangement possible? Yeah. Sulfur in the middle, and the oxygens on the north, south, east, west side. Remember, give the central atom 8 electrons. 2, 4, 6, 8. So I am now down to 24 electrons. The other ones are going to go on the outside. All your remaining electrons probably will give the outer atoms 8 electrons. So 2, 4, 6, 8. That oxygen's happy, 2, 4, 6, 8. This oxygen's about to be happy. And that one. So I had 24 electrons left. Here they are. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. That is the structure for SO4 minus 2. So these were the basics. I have some practice ones that you'll be doing shortly. I hope you enjoyed this lesson. Thank you very much.